Welcome to today's webinar on future-proofing your security for the post-quantum era. Thank you for joining us from around the world, whether it's morning, afternoon, or evening in your time zone. Today, we'll explore how the new CyberVault HSM series sets new standards in performance, scalability, and post-quantum readiness. You'll also gain insights into how our solutions integrate seamlessly with a wide range of technologies, enabling secure deployment across IT environments, whether on-premises or in the cloud. It's now my pleasure to hand over to our CEO, Robert Roggenmoser, who will start us off with a brief welcome and introduction to Securasys, and then introduce today's speakers. Robert, over to you.
Thank you, Mina. Let me start with a simple thing all of us do pretty much every day. We go to a website, and in a website, typically these days, all websites are authenticated. They have a certificate. You can check if it's valid, like this one here. But this is just one piece of cryptographic content that's there, the certificate to verify the websites. Underneath the website here, there is tens of services that are all authenticated, connected through the internet. And this looks something like this. You have different systems, different clients, different communication protocols, different processes running on Kubernetes in Docker containers, and they authenticate each other. They're connected through TLS, which has authentication and encryption built in. There is HTTPS in it, there is ingress control in it, NGINX, and so on. And everything needs cryptographic keys. Now, if you have a good system, secure systems, you store these keys in HSM clusters because they're critical to protect your infrastructure. Now, up to now, we have all used algorithms like RSA, ECC, Diffie-Hellman. The problem with these algorithms is that the black swan that's coming up is on the horizon. The quantum computer can break these algorithms. It might be in 5 years, it might be in 50 years, but it's coming. So NIST has worked over several years to create new algorithms. They have about 100 candidates, tested all of them. A lot of them were broken right away. A lot of them lasted a little bit longer, but 3 candidates were actually certified by NIST and released end of last year. These are MLDSA, MLCAM, and SLHDSA. So these are the new algorithms that are released by NIST to do post-quantum computing authentication and key exchanges. It's not done yet with these 3 algorithms. There are more algorithms coming, and we have to update all the systems with these new PQC algorithms. This will take 5 to 10 years, and we have to start now. Also, we have to make sure that the systems we deploy today are able to be upgraded with these new algorithms in the future. If you look back, the SHA-1 to SHA-2 transition took 5 to 10 years, which was a very simple thing to compare to what we're doing today. Later on, Marcel will show you a slide of all the systems that are affected by this. The timeline has been ongoing here. There is several things we need to do. The NSA has a plan to have everything moved over, changed to the PQC algorithms by 2033. Some stuff need to be done by 2030, like software and firmware signing, which they actually want you to do right away already now in 2025. In today's webinar, you already met Mina, our marketing director. The next presenter will be Marcel Dasen, our Senior Vice President of Engineering, followed by Peter Fernandez, who will talk about the integration overview. He's a Senior Product Manager and Application Engineer at Securasys, and I will close out with a few points about Securasys and handle the managed Q&A. With that, I'd like to pass the baton over to Marcel, who will talk about the future of HSM technology. Marcel, please.
Thank you, Robert. With all these challenges at at the horizon. We have a new product which has been built to conquer those challenges. It's the new CyberVault HSM, as we have named it. I would like to start with a short picture. The CyberVault family, it comes in two flavors, the Pro Enterprise Max mechanical design, which has smart cards for authentication and a touch screen, which allows you to completely control the device, in a more pure economical design, which omits the smart cards and display. Of course, you can still add the same functionality, meaning smart card and display, using our Decanus remote access terminal. So what are the challenges? We have heard about the PQC, but that's not the only challenge we are seeing. If we look at this slide, we can see on the left side the traditional way on how secure key storage in the form of HSM have been used. So there was an application deployed together with the application, an HSM, or rather typically two HSM, each having one connection to the application, so that if one of the HSMs fails, the other takes over, and the keys are securely stored in those two. And of course, companies typically also prepare for complete sites going down, so the whole system is also replicated to another location. So we have two data centers where basically the same application is deployed, and the other data center can take over when one is going down. The modern world looks slightly different. You still have, of course, multiple data centers or maybe hyperscalers where the application is run as pods. Pods meaning also microservices. So if a client connects, a pod is launched to serve exactly this one client, or it can also serve multiple clients and is dynamically scaled. For example, with a Kubernetes cluster, which will launch pods or containers whenever they need it. If we look at what happens now is, of course, all these pods need access to those secrets keys. It's probably not the best idea to have them stored in a shared environment. So they should be back in the HSM. As a matter of fact, they should be back in a cluster of HSMs, because you need replication there as well. And what you can easily identify is now that the HSM has to have multiple connections, or has to accept many, many more connections, which can be thousands potentially. The other big challenge, we have heard it, is post-quantum readiness or resilience to post-quantum computers, or to quantum computers. As said before, we have a new set of algorithms. So things like MLDSA, which is this new digital signature algorithm based on lattice-based cryptography. It will replace RSA, ECDSA, EDDSA, which we have been using eventually. Its typical use is electronic IDs, TLS authentication, SMIME security, SSH authentication, and things like this. It's standardized in a standard called FIPS 204. Then also the way we have been establishing keys in the past, typically in connection scenarios, again, VPNs or TLS between different entities, like your web browser and a server. There is no one-to-one replacement for the Diffie-Hellman algorithm. Nobody has come up with a suitable mathematical structure to do this. So the key establishment is done using sort of a key encapsulation mechanism that's called the MLChem. Again, it is based on lattice-based cryptography and standardized in FIPS 203. SLHDSA is another digital signature algorithm. In principle, it can replace RSA, ECDSA, etc. as well. And it is a stateless hash-based signature. And hash-based signatures typically have a few disadvantages, like very long key creation times, large signatures, not optimal run times. Thus, it can be a good solution for code signing and a very safe one, because these signature schemes have been have been here for a very long time. They could be used for document signing, but they may not be the optimal choice when it comes to authentication purposes. Again, FIPS has, or NIST has standardized this in the document FIPS 205. And for very high security application, it might be the right choice. Upcoming here, grayed out, is FNDSA, yet another digital signature algorithm with FIPS 206. It is also based on lattice-based cryptography. It uses slightly different ways on how the error is introduced, or how the mathematical properties are done. Has smaller signatures, which can be important in some applications, a different runtime behavior, and also a different trade-off when it comes to implementation complexity. Not to forget are standards which have been there for quite a while, the SP800 208. These are stateful hash-based signatures like LMS or XMMS. These are algorithms where you have to decide at key creation time how many signatures you plan to make, and you can not extend that. So these things can be useful for code signing. If you make a key which maybe can do whatever 10 million signatures, you probably save for a very, very many code deployments. If we look what we have to do now that these new algorithms are around, and in our products they are shipping, which is very nice, but it's only half, or actually, matter of fact, it's probably 5% of the challenge, because the challenge is layered. It's layered, meaning that it is available on the IC level, where new TPMs have to be made, new smart cards have to be rolled out. They don't even exist at the moment, neither do the TPMs, which you have in your computer, probably sitting on your desk. Secure enclaves to attestation, still using classical algorithms, and also CPU crypto accelerators today are optimized, of course, for the classical algorithms. On the next layer, components like disk encryption, where the key that is encrypted is probably wrapped with an RSA or elliptic curve. MACsec, a very basic protocol, which you use between your routers typically. Unfortunately, there the protocol is written in a way that it is not easily accessible for those large signatures. So as a matter of fact, the protocol has to be updated, and you can imagine that if the protocol has to be updated on all sides on a very basic layer, meaning just above the optical link, that can become a very long-term proposition. Bootloaders, BIOSes all use cryptography for authentication, need to be changed. Authentication protocols for the network as standardized in 208.1. Also, at the moment, can only support classical algorithms, and will need protocol updates before being rolled out. Since this is your basic infrastructure, your switches, your routers, your firewalls, for rolling out those changes, you have to consider that you have to replace potentially, likely, all of those in the field, which probably is going to take at least 3, probably more like 6 years. Infrastructure layer, things like ingress controllers, NGIX, or Apache, where you do TLS termination. You need to update in order for those to work. Of course, you would probably want to have OpenSSL, because this is the most used crypto library, which fortunately just came out 2 days ago with the version 3.5, which does support post-quantum. Of course, we'll have to make sure that all these things which are now being deployed also are interoperable when it comes to formats. VPN, iKey, again, typically use classical algorithms, and CMS, SMIME the same thing. So a lot of protocol changes that need to be rolled out in those committees. And, protocol committees or standardization committees are not working terribly fast. A little easier is the problem to be solved when it comes to authenticated tokens, which you use in your single sign-on logins like JWTs and SAML, or also code packages. Think that your Linux or Windows system gives you the code in a signed version. And of course, these signatures today are based on classical cryptography. And even your crypto libraries in many cases are not ready. They may support some pre-standard round algorithms, but need to be updated to the final version NIST has standardized. The further up we come, the easier sort of becomes to replace individual elements, things like SSH, HTTPS, syslog, SNMP. All those daemons typically use authentication based on cryptography and of course need to be updated. While this probably can be done much easier, it still is going to take some time before you're able to deploy that. On the application layer, as a matter of fact, there the problem is the smallest, and that's also why we already see products out in the market like PKIs or public CAs, which give you certificates based on post-quantum cryptography. You may wonder why DBs are here on the list. DBs typically use symmetric encryption to encrypt columns or the whole database. But unfortunately or fortunately, they also typically wrap those symmetric keys in asymmetric cryptography. Another notable example is Windows. Windows at the moment does not support post-quantum at all. It also needs a bigger update, as some of the tools we're happy to work with, like MS SQL DB or things like this, still use a long, technically deprecated crypto API from Microsoft. And of course, those would have to be updated, first of all, to the new generation, where the new generation crypto API is already probably 10 years old, and then also to post-quantum. And if we have looked at the roadmap from NSA, code signing, of course, we need sign tools to do the code signing. And unfortunately, also here in Windows, sign tool is not supporting post-quantum yet. But we can expect these things to happen in 1 to 2 years. So give me the opportunity to talk a little bit about our new product features. As optical interfaces become more ubiquitous in data centers and doing encryption everywhere requires much higher transaction loads, our new product has been designed to support this. So all our products now have potential for optical 10 gig links with SFP+, in addition to the traditional copper links. Putting out an infrastructure which is used in basically all your IT, you need a lot of tenants so that your applications can be separated. And of course, if you have a lot of tenants, you need a lot of key space storage. Then certified, and the point here is really certified PQC algorithms, very important. It is important mostly for interoperability so that systems of different vendors can interoperate needlessly. High performance for PQC and classical crypto. So in many cases, you will have loads which still remain on the classical crypto, and you have maybe new applications which have already transitioned and need PQC support. In some cases, it may make a lot of sense to go the hybrid way, meaning that your certificates are signed as well with post-quantum algorithms and classical crypto, which also means that you have to have high performance or the same performance for classical and post-quantum cryptography. Also in our new products, we have focused on some other pain points we have seen from the market. Even easier setup and installation procedures than we had before. Here the keyword is deploy first and set up later, meaning you can ship the device to the rack and then semi-automatically get it set up. We have optimized on segregation of duty. There are new smart backup and restore functionality, which are more apt to cloud-based environments. And we have extended certification and attestation to all elements of the product we're shipping, from keys to logs to configuration to diagnostics, which all can be attested. Okay, now you're probably wondering what is the performance characteristic of this baby. It comes in different flavors, and of course it has been designed for the load we are going to expect. So it starts out that the platform is ready for more than 50,000 transactions per second. What does that mean? If there are different operations running at the same time, we can handle in excess of 50,000 things in parallel. That could be something like a large load of AES small block operations or ECC ED operations. Of course, if we go to RSA 4K, it is not exactly in the same range because this is dramatically more demanding, but still for very high performance, we can still support up to 4,000 4K operations per second. And then we have the non-classical algorithms, the post-quantum algorithms, where the device has already been optimized to support up to 20,000 MLDSA signatures and more than 30,000 MLChems. Now, I think that is a notable number because at the low latency the device has, and this high performance number for key establishment, it can actually make quite a bit of sense to use the device also as a crypto accelerator, and with this increasing the performance of your application server. If a single device is not enough, and as said, typically you should not deploy a single element, you should deploy a number of HSMs for redundancy. You can scale these clusters up to 64 devices, and in a large configuration like this, you can achieve more than 1 million transactions per second over the cluster for a single application, or more than roughly 3 million if you have multiple applications using the device. Clusters also give you load balancing between the cluster members. They give you high availability, redundancy, and a speciality of our devices. A cluster can actually span large distances. It can be deployed completely across the globe and not just across a data center. So, how does it look like from the front and from the back? We have seen the front before. Notable are, of course, hot pluggable dual power supplies, modern connectors like USB-C for attaching storage or other things. As a matter, it's only storage which can attach. Console now RJ45, which is more common in a data center. Then we can see the two SFP Plus slots for 10 gig Ethernet, and concurrently working also for traditional copper 1 gig links. On the front side, you can see 3 smart card slots and a touch display, which is a capacitive touch, and allow you to do all security officer or net or setup operations directly on the screen. The more pure and economical design, the Cyberwall Core, omits the display and the smart card slots, but it shares with the more capable devices also the the networking interfaces. So it also comes with dual 10 gig SFP plus and 4 copper, and has otherwise also the same connectors and hot pluggable power units. With this, no, not quite. I'm not quite ready. Yes, I would like to show you the different SKUs which we have. They do differ in deployed cryptographic resources. So they differ obviously in cryptographic performance. So there's the core, which is the economical device, the Pro, which is the entry level of the more powerful series, and as such, it is full featured and serves a large part of the market. The Enterprise is sort of a more powerful version of the Pro, which can be license upgraded in field. And then we come to the more hyperscaler type devices, which have a very high performance in a high density environment, like the Max and the Max Plus, which are mostly for hyperscaler type or cloud type of performance applications, where form factor to power to computing power really matters. With this, I think I'm done, and I would like to give over to Peter.
So the next minutes, I'd like to give you an overview of the integration landscape. As shown by Marcel, post-quantum algorithms on the application level might still take some time. On the other hand, not to forget, for HSM integration, it also depends on the chosen API. For example, our REST and Java APIs, in combination with the latest firmware, already support the NIST-selected post-quantum algorithms. And you can actually start today with application integration. The standard HSM API is based on the PKCS 11 standard, for which we are still awaiting final specifications. As Marcel said, the timeline for applications using Microsoft cryptographic API remains uncertain. So now let's look at some popular key factor applications like eJBCA Enterprise, a public infrastructure solution for large enterprises, the open source eJBCA Community Edition, and Sign Server, a multi-purpose signing solution for document signing, code signing, timestamping, and e-passports. Our HSMs are integrated into eJBCA since a while using PKCS 11. This API, however, has some drawbacks like required code installation on the client side, some complexity, and lacking PQC support. Now, the good news is that eJBCA supports our REST API with advantages like easy deployment without software installation, reduced complexity, support for NIST-selected algorithms, and the HSM features automated key attestation, including audit trails for compliance in legal and regulated environments. Using REST, eJBCA also supports enhanced key security using smart key attributes, a feature that lets you apply custom rules to individual keys, including usage policies, time restrictions, and multi-party quorum approvals, which can easily be authorized using the mobile authorization app. So eJBCA Enterprise version 9.1 using the REST API in combination with on-prem or cloud HSM is post-quantum ready and fully supports enhanced key security with the smart key attributes. The Sign Server Enterprise REST integration is planned to follow in May this year. eJBCA and Sign Server software appliances have both REST and PKCS 11 API fully integrated and configurable via web user interface. eJBCA Community Edition supports PKCS 11. Fortinet, one of the market leaders in hardware firewalling and web application proxies. The FortiGate next generation firewall is available as special build, having PKCS 11 API integrated. The firewall offloads key generation and usage to the HSM. General availability is expected later this year. The Fortinet Web Application API Protection solution was recently launched and generally available. Securusys PKCS 11 is fully integrated and configurable via CLI and web user interface. Fortinet solutions rely on SSL TLS protocol and PKCS 11, and therefore PQC is still pending. Let's look quick at other solutions where HSM integration is beneficial. HashiCorp Vault Enterprise, an identity-based secrets management platform, uses PKCS 11 and provides some interesting features like HSM-based Vault auto-unsealing and entropy augmentation. The Vault Community Edition and the OpenBAO fork support REST-based HSM integration. Additionally, a REST-based Secrets Engine plugin allows Vault key management on the HSM, including PQC and SKA. For AWS Key Management Service, we offer the REST-based external key store proxy. That gives full key sovereignty by keeping your keys securely on the HSM outside the AWS cloud. Docker containers have become a cornerstone of modern application development, having many advantages. So container security becomes essential to maintain trust and compliance. Here we provide REST-based integrations for Docker image signing and encryption, supporting PQC and smart key attributes to control usage of the key. There is a bunch of identity and access management and credential management solutions, all integrating HSMs based on the current PKCS 11 standard. CyberArk Privileged Access Manager Venafi solutions in machine identity management, secured and unified privileged access management, VersaSec, Nevis, and so on. Majority of these solutions are awaiting final PKCS 11 specification. Bring Your Own Key got popular as it allows organizations to retain ownership and control of keys even when using cloud services. PQC support depends here mainly on the key wrapping mechanisms and the applications themselves. This, of course, represents just a small solution selection among many others. Just a few words to OpenSSL version 3. With OpenSSL version 3, the architecture for integrating components like PKCS 11 key stores changed to a new provider model, while the previous engine mechanism will get sooner or later deprecated. But no worries, the provider model is already the preferred way for Securusys HSM integrations. And OpenSSL version 3.5, Marcel already mentioned. More solutions and integration details you can find on our public integration documentation page, browsing to docs.securusys.com and selecting the HSM Solutions Explorer. With this, I finish my presentation and pass back to Robert for the question and answer session.
Thank you, Peter, and thank you, Marcel. Let me switch on the slides here again. So, summarizing, we have a great new lineup of our CyberVault HSMs. The basic entry-level CyberVault Core, then on the low end for the higher end, for the top models is the CyberVault Pro, the CyberVault Enterprise, the which is field upgradable. And for the high end and the top high end, we have the CyberVault Max and the CyberVault Max Plus. Some of you are new to Securasys. Let me tell you a little bit about our company. We've been founded in 2014, owned by the founders, employees, and a small group of Swiss investors. Our big reference card is that our HSMs are protecting the Swiss interbank clearing and the Swiss stock market transactions, where we have over 100 billion in daily transactions. We're doing this since 2016 and could renew our contract, and it's now valid until 2034. So we're going to be around for quite a while. We have many customers in many countries. Our headquarters are in Switzerland, in Zurich. We manufacture and design and manufacture here in Switzerland, so it's Swiss-made boxes. We have sales offices in the UK, Singapore, and the US, and subsidiaries currently in Hong Kong and Germany, and we're are actually in the setup for a US subsidiary, not UK, US subsidiary. If you don't want to run your HSMs by yourself, we actually run our own cloud HSM service in 7 data centers across the world. We have 2 data centers in the US, 4 data centers in Switzerland, 1 in Singapore, and have another one planned in the region. With that, I'm getting to my last slide, and thank you for your attention. And we're now starting to answer questions. Marcel, one of the questions we had in the morning is like, our HSMs are field upgradable, of course, and so NIST is coming out with new algorithms, so how long does it typically take you to get these algorithms built into the HSMs and released to the market?
Yeah, thank you, Robert, for the question. Yeah, I think the important point here is that all these devices are field upgradable by firmware. We do regular updates, and with an update, we can ship also new algorithms. As we do cryptography using FPGAs, we can even update the hardware to the latest standards if required. How long does it take? Once the algorithm is standardized, I think we can, within a few weeks, months, 1 month, we can make a working prototype, which we can roll out on our dev. And typically within 3 to 6 months, there will be a public release.
Yeah, so there is they say 3 months, maybe 6 months after it has been released. I think we were quicker with our release after the NIST released the first algorithms. The other step here, though, is the NIST certification of these algorithms. So, I mean, our current algorithms are already certified by NIST. Is this true?
Absolutely. So we do ship certified algorithms and plan to do that in the future. We have also structured our firmware package such that we can add new algorithms, including new certs when those algorithms become available.
Good. Thank you. There are still no questions. You can type in questions in the Q&A. Hit the Q&A button and type in your questions. So the algorithms are certified by NIST, Marcel. How about the box? How about the HIP certification and common criteria certification?
Yes. Yes, certification, of course, is an important topic. So the new and, as a matter of fact, the old boxes are in certification for the latest firmware we have. As a matter of fact, for quite a while already. In common criteria, we are certifying against the 4.19.221-5, the AIDA's well-known public profile. Also, at the same time, we are certifying against the SAM profile. That's the profile which makes sure that keys can be used with sole control, also for qualified digital signatures. We expect that we will see certification in the common criteria by the end of this year, Q4. When it comes to NIST, I think by the end of the next quarter, as a matter of the end of this quarter, we should have a statement from our lab, but I think the certificate from NIST is quite a long way out. The waiting queue at the moment is almost a year and a half since everybody is transitioning to FIPS 140-3.
Yeah. But we're working on it and it will happen. So it's just a matter of time. So that's what you're telling us.
Yes, but for all the algorithms, obviously we already have the certificates and they're publicly listed.
Okay, so people can use the CyberVault HSMs and start testing their systems with PQC algorithms. There is a question in a Q&A thing. Do you implement algorithms before certification to get ahead of the curve? So I think we did we? Didn't we, Marcel? So
yes, we did. And if you are current customer of ours and are running on firmware 3.0, whatever release version, you would have the ability, and I think you still have in later ones, the ability to use the pre-certified round 3 algorithms. So we have been rolling them out quite early for people to be able to test. Unfortunately, those round 3s are, of course, in many cases not interoperable with other round 3's implementation, which definitely must not be the case with the FIPS ones. But you can have both if you want to. Not that I think now that the certification is there, you have any interest in the round 3 algorithms.
Okay, there is yet another question for you, Marcel. What is the performance of MLDSA 65 and 87 compared to 44?
Yes, I now this time I'm better prepared than this morning. Hold on for a second. I do have those numbers. So I can give you a scalability roughly from MLDSA to MLD44 to MLDSA 87 is typically roughly a factor of 2. It's not quite, it's a little bit less. So when you have seen those numbers,
2x faster or 2x slower?
Well, that depends where you start from. So it's when you start as a reference with 4.4, then it's roughly half, a little bit more than half the performance.
Okay, so it goes down a little bit, but not really much in that sense.
Yeah.
Good. If there are no further questions, and I don't see any further questions, I pass it back to Mina to close out our session, our webinar.
Thank you, Robert, and thank you as well to our speakers, Marcel and Peter. And of course, a big thank you to all of you in the audience for spending your time with us today. We hope this session has been valuable to you, and we look forward to reconnecting with you very soon. As we have already mentioned, and Robert had said this as well, we'll be sharing the recording with you as soon as it's ready, at the beginning of next week. If you have further questions, please don't hesitate to contact us. We are happy to assist. And with that, thank you very much again. Goodbye from all of us at Securasys, and take care. Bye.